Welcome to this predicted paper. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by clicking the link. Our website is full of free content to help you with your exams. You can even save your scores with a free account. Enjoy! At a business conference, 60% of attendees are industry professionals and 40% are students. Jasmine and Leo plan to conduct a feedback survey. Jasmine decides to use simple random sampling to select 50 participants. She uses the official attendee list as a sampling frame, assigning a number to each participant. She then generates 50 random numbers and selects her sample accordingly. Leo decides to use quota sampling to collect a sample of 50 participants. He plans to stand at the registration desk until 30 industry professionals and 20 students have been interviewed. Give 2 reasons why Jasmine's method may not produce a sample of 50 participants. Let's start by looking at Jasmine's method. She's going to assign a number to each participant and then generate 50 random numbers. So let's visualize this. Say we've got 3 people and the first one's got the number 31, then 52, and then the last one's got the number 3. We use our random number generator and we come up with 3. And so we've picked that first person. But then we use the random number generator again and we get a 3 again. Well, what happens then? We've got the same person picked twice. Now we use the random number generator again and we get the number 35. But that doesn't really correspond with anyone. So if we were to do 50 random numbers, then some might come up again, and also some may not correspond to a person. Our answer will be that some of the random numbers may be repeated, and the random number may not correspond to a person's number. Give 2 advantages of quota sampling. With quota sampling, you don't need to number the population and have a random number generator. All you need to do, say in this instance, is pick the first 30 professionals you see and the first 20 students you see. So quota sampling is easy. Also, if you were doing it randomly, for instance, if Leo did it randomly, they may all be professionals. All 50 of the people he picked may be professionals. He's making sure that his sample is representative. So the benefits of quota sampling is that it will represent the population. Explain why the quota sample used by Leo is not a random sample. For a sample to be random, every single member of the population must have an equal chance of being picked. For Leo's method, he's standing by the registration desk and picking the first 30 professionals and the first 20 students who come across the desk. So the people who come out last will have a statistically 0 chance of being picked. So it is not a random sample because not every attendee has an equal chance of being selected. The map below shows the percentage change in domestic tourist visits across different regions of England and Wales between 2010 and 2011. Write down the percentage change in domestic tourist visits between 2010 and 2011 in Wales. Looking at our diagram, Wales is here, and you can see the shade here is this shade here. So we're looking at this answer here, which will be a 0 to 2% increase. There are 10 regions shown. Find the number of regions that the domestic tourist visits increased. Looking at our key, there is only one of these that show a decrease, and that's the white one. Looking at our map, there is only one region that is in white. Therefore, if there are 10 regions altogether and one that showed a decrease, then there will be 9 that increased. Bryant states that the domestic tourism in England and Wales increased overall between 2010 and 2011. Explain why this may not be the case. Looking at the map, every single region apart from Anglia increased, and Anglia was the only one that decreased. So chances are there was an increase overall, but we're not given the amounts. It could have been Anglia decreased by 10 million and all the other regions added together only increased by 1 million. We don't know the amounts. So our answer needs to say that we only know the percentages, not the amounts. State the statistical name for the type of map shown. A map that uses colour to show information is called a Choropleth. Sophie recorded the heights of male and female students in a school. Both groups were measured using the same method. The box plot shows information about the heights for the male students. The table gives information about the heights for the female students. Draw a box plot for the heights for the female students. The female students' heights are given to us in the table, and the least tall was 150. So on our graph here, I'm going to draw a line at 150. Then the lower quartile was 158. And we can see here that each of the little squares is going to be 2. Then the median is 162, so we'll make sure that goes there. Then 172 is going to be there. And then 190 is the most tall. Now we need to join these up properly. So we have our little whiskers here, and then we've got the box here. Make sure I get this right. There we go. Compare the two distributions of heights. Give 3 comparisons and interpret one of these comparisons. We're going to start by comparing the medians. Now the medians for the males was 170 and for the females it's 162. So in the comparison we're just going to write the median heights for the male students is greater than the female students. Next we're going to compare the interquartile ranges. So the interquartile range for the males was 178 take away 162, so that's 16, and for the females it's 172 take away 158, so that's 14. So we're going to say that the interquartile range for the height of the male students is greater than the female students. Next we're going to look at the skew. So looking at the male box plot, it looks pretty symmetrical. Now for a previous question we did the box plot for the females, so I'm just going to show that now. And you can see that the skew for the females is positive, because if you look at this gap here and compare it to this gap here, and same with the distance between the median and the upper quartile compared to the distance between the median and the lower quartile, it's definitely a positive skew. So if we go down, then we can say that the skew for the heights of the male students is symmetrical and the skew for the female students is positive. Finally, we're asked to interpret one of the comparisons. I'm going to interpret the median heights being bigger for the male students and say that the male students are on average taller than the female students. It is estimated that 2% of a certain type of medical test gives a false positive result. The remaining tests provide accurate results. David took 2 such tests. He does not know if each test result is a false positive or accurate. Complete the probability tree diagram. Each of the false positives will be 0.02, so we can put that onto the tree diagram, and each probability have to add up to 1. So if the chance of a false positive is 0.02, take that away from 1 and you get 0.98. So each of the probabilities of an accurate result is 0.98. Find the probability that both of David's test results are accurate. With a tree diagram, we always start here, and if both of the tests are accurate, we're going to go down here, and then we're going to go down here. And all of the probabilities we collect along the way, what we're going to do is multiply them together. Because in probability, the word and it's accurate and accurate, means times. 0.98 times 0.98 is 0.9604. David states that the probability that exactly one of the tests is false positive is less than 4%. Find out whether or not David is correct. Looking at the tree diagram, if the first test is a false positive, the second would need to be accurate for us to have exactly one false positive. Looking along, it would be 0.02 times the 0.98, which will give us 0.0196. If the first test was accurate though, The second test would have to be a false positive to again give us that one false positive. But this is going to be 0.98 times 0.012 again. So this is also going to be 0.0196. Now with tree diagrams, if you've got two answers here and here, and you want to find the total probability, it's either going to be this one or this one. The word OR means add. So what we're going to do is we're going to do 0.0196 add the other 0.0196, or just times it by 2. That will give us 0.0392. Now looking at what he is saying, he's saying that it's going to be less than 4%. So we need to convert this into a percentage. And we can do that by multiplying it by 100. So it will give us 3.92%, which is indeed less than 4%. And finally, we just need to write down what we found. So the probability of exactly one false positive is 3.92%. So David is correct because this is less than 4. Always make sure you say either that the person is correct or that they're wrong. The cumulative frequency step polygon shows information about the number of books borrowed from a local library over 70 days. Give a reason why a cumulative frequency step polygon has been used to display this data. A cumulative frequency step polygon is perfect for this situation because the number of books borrowed is discrete, meaning that you can't get 1.5 books. You either get 0, 1, 2, 3, etc. Find the mode of the number of books borrowed. You can find the mode on a cumulative frequency step polygon by looking at how much the line goes up. So it goes up a little bit here for 0, quite a lot here for 1, a tiny little bit here for 3, but by far the most it goes up is here for 4 books borrowed, and then a little bit for 6. So 4 is by far the most, so therefore 4 is the mode. Find the number of days where there were exactly 2 books borrowed, more than 2 books borrowed. If we look at the cumulative frequency step polygon for 2 books borrowed, notice that it doesn't go up at all. Therefore, for exactly 2 books borrowed, it's going to be 0. For more than 2 books borrowed, we can draw a line across from where we're currently at 2, and it's going to be all of these here. And so it goes up to 70, and we're at 25. So the distance here is going to be 70 take away 25, which is 45. So the more than 2 books borrowed is going to be 45. In 30 days, fewer than X books were borrowed. Find the value of X. We can draw a line across from 30, and we can see that all of the jumps up to the line are under 4. So our answer is going to be 4. Laura believes that the interquartile range of the number of books borrowed is 8. Explain why the interquartile range for this data cannot be 8. Looking at our cumulative frequency step polygon, the first time this graph goes up is at 0, and the last time it goes up is at 6. So the range will be 6 take away 0, which is 6. The interquartile range must be less than the range. So our answer is that the range is 6, so the interquartile range must be less than 6. The Venn diagram illustrates the probabilities associated with events A, B and C. Identify the 2 events that are mutually exclusive, giving a reason for your answer. Looking at the Venn diagram, events A and events C do not overlap at all. So A and C are mutually exclusive because they do not intersect. Find the probability of B. To find the probability of B, we just need to add up all of the probabilities in B. So we're going to add 0.31, 0.12 plus the 0.02, and that's going to equal 0.45. Find the probability of A or C. Because we're looking at the probability of A or C, we're looking at adding up all the probabilities in A and all the probabilities in C. So we're going to add up the 0.05 and the 0.31 in A, and the 0.02 and the 0.28 in C. When we do that, we get 0.66. Complete the Venn diagram to show only the probabilities for events A and B. The left-hand side will be identical, so this circle here is going to be exactly the same because it just represents the same thing. This is only A, and then this is the overlap with B. The part here that is only B, not only is this number here, but is also this number here. Because C doesn't exist in this new Venn diagram, we're just going to add these two parts together. 0.12 plus 0.02 is going to be 0.14. And finally, we're looking at all of the probabilities that aren't in A or B, so it's both of these ones. So the final part, the bit outside the Venn diagram, is 0.5. Always check that all four of these add up to 1, which they do. Ethan is researching the average GCSE grades and their rankings in the local newspaper for 10 schools. Suggest a diagram that Ethan could draw to determine if there is a relationship between the average GCSE grades and their rankings in the local newspaper for the 10 schools. When we're looking for a relationship between two variables, we've got bivariate data. The way we show that relationship is with a scatter diagram. Part 1. Calculate Spearman's rank correlation coefficient from the table. To start, we're going to have to work out the D and the D squared column. To do this, we just subtract the rank. So 7 take away 9 is the minus 2 there. 8 take away 5 is 3, etc. So we've got 3 take away 3, which is going to be 0. 9 take away 8, which is 1. 10 take away 10, which is 0. 5 take away 4, which is 1. 6 take away 7, which is minus 1. And 1 minus 2, which is minus 1. Then, to get the D squared column, we just square the D's. And essentially what we're doing here is making everything positive. So 0 squared is 0. 1 squared is 1, 0 squared is 0, 1 squared is 1, minus 1 squared is 1, and minus 1 squared is 1. Now we add the D squared column, which gives us 22. Next we're going to use the formula. Now the formula is given to you don't need to learn it off by heart. The sum of D squareds at the top is 22, so the top of the fraction is going to be 6 times 22, and n is the number of schools, which is given to us in the question, or you can just count them from the table. Put all of that into your calculator and you'll get 0.86666 or 0.87 to 2 decimal places. Part 2. Interpret your answer in the context of Ethan's research. You will need to refer to the effects of any outliers. The key part in this question is that it says in the context of Ethan's research. So we know that the answer to part 1 was 0.87, which is a positive number. So we know that there's a positive relationship between the two rankings. But in the context of Ethan's research, we need to talk about it in terms of as the average GCSE grades increases, their rankings in the local newspaper also increase. So you're showing that relationship in the context of the question. If we had any outliers, the presence of them would decrease the correlation. Anytime you have an outlier, by definition, it will decrease the correlation, because if it helps the correlation, it wouldn't be an outlier. Discuss whether Ethan should have used Pearson's product moment correlation coefficient instead of Spearman's rank correlation coefficient to measure the correlation. It's really important to highlight in this question that the product moment correlation coefficient is only good for finding linear relationships, because it's essentially looking for the line of best fit, the distance between each of the points and the line of best fit. So you shouldn't use the product moment correlation coefficient because it only measures a linear correlation. Also, the data in the question is ranked. Ranked data is really good with Spearman. So Spearman's rank correlation coefficient is used for ranked data. The pie charts show the budget allocations for a business in November 2015 and February 2016. Explain why the pie charts do not show a larger marketing spend in February 2016 compared to November 2015. This question can seem quite confusing at first because the marketing in 2015 is 38% and it grows to 42% in 2016. So it seems like it's going up. But remember, that's just showing the percentage of the total budget. It's not showing the actual amount of budget. For instance, if in November 2015 the budget was £10 million, but in February 2016 it got slashed to £5 million, well, 42% of £5 million is a lot smaller than 38% of £10 million. So November 2015 could have had a larger total budget than February 2016. The marketing budget in November 2015 was £58,748. Find the R&D budget in November 2015. The marketing budget was 38%, so we're saying that 38% is going to equal 58,748. Therefore 1% will be this 58,748 divided by 38, which is 1,546, and we're looking for the R&D budget, which is 24%. So we're looking for 24%. So all we need to do is the 1,546 times 24, which is 37,104. So our answer is £37,104. In November 2015, the total budget was 155,000 to the nearest thousand. In February 2016, the total budget was 185,000 to the nearest thousand. Gemma wants to use the totals to draw pie charts. Explain giving reasons how Gemma can use the totals to draw these pie charts. This question is hinting at you to suggest a better pie chart to use. The pie charts we use at the moment are just showing the proportions, but we have the totals now, so Gemma can use comparative pie charts. With comparative pie charts, the areas are proportional to the frequencies, and we need to work out how much bigger one of the pie charts is going to be than the other one. So we're going to have our frequency 1 going to be this 185,000, and our frequency 2 is going to be the 155,000. And to work out how much bigger the second one will be, we just square root the F1 over the F2. So we're going to square root the 185,000, but actually we don't need to write 185,000 because it's a fraction, so the thousands will cancel anyway. You can do if you wish. And that will give us 1.09 rounded to 2 decimal places. So what does that 1.09 mean? That 1.09 means that the February 2016 pie chart is going to be 1.09 bigger than the November 2015. Essentially, the radius or diameter will be 1.09 bigger. And we need to make sure we write this in a sentence. So the radius of the November 2015 pie chart will be 1.09 times larger than the February 2016 pie chart. So far we've explained how Gemma can use the comparative pie charts, but we haven't really given any reasons. So the final thing is to just state the reasons that the totals for these pie charts are different, so the areas of each pie chart will represent the totals whilst keeping the proportions the same. A company bottles soft drinks. The bottles have a target volume of 500 millilitres. The company uses quality assurance to monitor the volume of soft drink in each bottle. Samples of the bottles are taken from the production line at regular intervals, and the mean volume of soft drink in the bottles in each sample is found. The sample means should be normally distributed with a mean of 500 millilitres and a standard deviation of 3 millilitres. Find the upper action limit for the sample means for the bottles. The upper action limit is 3 standard deviations above the mean. So we get the mean, which is 500, and then we add 3 lots of the standard deviation. So it's going to be 509. So it'd be 509 millilitres. The upper action limit will be set closer to the target volume of 500 millilitres. Describe the effect this will have on the frequency of production process stoppages. If we imagine this blue line is the volumes of our soft drinks, and this line here, this pink line, is our upper action limit, you can see that the lower it goes, as in the closer it gets to the target volume of 500 millilitres, the more the volumes of our bottles cross the line. And any time they cross the line, the whole production process needs to stop. So the production process would need to be stopped more frequently if the upper action limit was set closer to the target volume. The company also bottles tomato ketchup and uses quality assurance to monitor the volume of tomato ketchup in those bottles. Here are the control charts for the sample means and for the sample ranges of the volumes of tomato ketchup in the bottles. A sample is taken and is found to have a mean of 807 millilitres and a range of 43 millilitres. Use the sample mean and range to determine what action, if any, needs to be taken. Let's start by looking at this mean of 807 millilitres. On the control chart for means, we're looking at 807, and we can see that that is above the upper warning limit, but still below the upper action limit. Now let's look at the range of 43 millilitres. Looking at the control chart for ranges, 43 will be above the upper warning limit and the upper action limit. We're asked what action should be taken. The production process should be stopped as the range is outside the upper action limit, although the mean is outside the upper warning limit but not the action limit. The ages of a group of boys have a mean of 5.6 years and a standard deviation of 0.8 years. Liam is a boy with a standardised score of 0. Find Liam's age. Standardised scores are measured from the mean, so a standardised score of 0 will just be the mean. So Liam's age is 5.6. Daniel and Alex are both boys in the group. Daniel's standardised score for age is 0.9 years. Alex's standardised score for age is minus 0.5 years. Daniel is older than Alex. How much older is Daniel? To find the standardised score, we do the value, take away the mean, and we divide it by the standard deviation. But in this question, we're given the standardised score, and we need to work out what the value is. So let's rearrange this formula. Let's start by multiplying both sides by the standard deviation, and then adding the mean to both sides. So to find values, all we need to do is multiply the standardised score by the standard deviation and then add on the mean. To find Daniel's age, we're going to put his standardised score, which is 0.9, the standard deviation, which is 0.8, and the mean, which is 5.6, into our formula to find his age is 6.32. And we can do the same with Alex, and we find that his age is 5.2. Finally, we can subtract the ages, so Daniel's age take away Alex's age, which it will be 1.12. Arjun takes a sample of 4 boys from the group. He wants to calculate the standardised score for the sample mean of their ages. Part 1. Discuss the appropriateness of using 5.6 years as the mean in the calculation of the standardised score. If we look back at the question, the mean is 5.6 years for the ages of the whole group. So using 5.6 years for this sample is going to be appropriate because the sample mean will be close to the population mean. So since the population mean is 5.6, then the sample mean will probably be around 5.6. Part 2. Discuss the appropriateness of using 0.8 years as the standard deviation in the calculation of the standardised score. It may seem this is appropriate because the standard deviation for the whole group is 0.8 years, so you'd think it would be appropriate, but actually it's not going to be appropriate because the sample mean will be more closely distributed than the individual values. A study took place in Sweden to find if there was a relationship between daily exercise and resting heart rate of middle-aged men. The researchers found the equations of the regression lines for the relationships between the daily exercise, x minutes, and resting heart rate, y beats per minute, for gym members and non-gym members on weekdays and weekends. The table below gives the equations of the regression lines. Interpret in context the figure of minus 0.05 in the regression equation for non-gym members at weekends. We're looking at this minus 0.05 here, and you'll notice that it's the coefficient of the x. Now, x is the amount of minutes of daily exercise. So as the x increases, then the overall number will decrease because it's got a negative coefficient. So in the context of our question, for every 1 minute increase in daily exercise, and that is x, the heart rate, which is y, will decrease by 0.05 beats per minute. Compare the relationships between the daily exercise and resting heart rate in middle-aged men who are gym and non-gym members, including your comparisons reference to whether it is a weekday or weekend. Looking at our table, we can first of all notice that all of the coefficients of the x are negative. That means that for all middle-aged men, an increase in daily exercise led to a decrease in resting heart rate. Looking at the coefficients of the x for weekdays, we had minus 0.3 for gym members and minus 0.1 for non-gym members. Comparing that to weekends, where it was minus 0.25 for gym members and minus 0.05 for non-gym members. So the weekends were smaller. So to interpret that, as daily exercise increased, the resting heart rate decreased more rapidly at weekdays compared to weekends. Looking at the gym members, we had minus 0.3 and minus 0.25. And comparing that to the non-gym members, we had minus 0.1 and minus 0.05. So the resting heart rate of gym members decreased more per minute of daily exercise than non-gym members. The researchers would like to use a normal distribution as a model for the resting heart rate of gym members on weekdays. Part 1. Explain how they could check whether a normal distribution is a suitable model by drawing a histogram. The normal distribution requires the data to be bell-shaped, so what they could do is draw the histogram, and if the histogram is a bell shape, a normal distribution would be a suitable model. Part 2. Explain how they could check whether a normal distribution is a suitable model by calculating the averages and the standard deviation. The normal distribution is a symmetrical bell shape, so for a normal distribution, all the averages, that's mean, median and mode, are going to be equal, and also there are going to be 95% of the data within 2 standard deviations from the mean. If both of these things are true, then a normal distribution could be a suitable model. 20% of the emails a user receives are spam emails. Out of 3 incoming emails, the number of spam emails is recorded. Identify 2 conditions needed so that a binomial distribution is a suitable model for the number of spam emails in the incoming emails. For the binomial distribution, the events need to be independent, so each of the emails are independent, meaning that if you have a spam email, it's not going to increase or decrease the likelihood of receiving another one, that the probability remains the same. Also that there are only 2 possible outcomes, either spam or not spam. Calculate the probability as a fraction that all 3 of the incoming emails are spam. We're told in the question that the chance of us getting a spam email is 20%, and the question asks us to use fractions, so we're going to use fractions for this. So instead of 20%, we can do 20 over 100, or we could do 1 over 5. The chance of us receiving the first spam email is 20 over 100. For the second one, it will also be 20 over 100, and for the third one, it will also be 20 over 100. In probability, the word and means times, so it's the probability that the first one will be spam times the probability of the second one times the probability of the third one. Put that into the calculator and you get 1 over 125. Calculate the probability as a fraction that at least 2 of the incoming emails are spam. Before I get started, there are loads and loads of different ways of doing this. I'm just going to show you one possible method, and I'm going to look at getting the probability of there being 2 emails and the probability of there being 3 emails that are spam, because there's 3 in total, so it's either going to be 2 or 3. Now, we're going to first of all say that P is going to be our 20 over 100, or let's use 1/5 now, and Q is going to be the probability of not getting a spam email, which will be 4 over 5. Using Pascal's triangle, we know that it's going to be 3 P squared Q for the probability that X is 2, and then it's just going to be P cubed for the probability that X is 3. And let's work this out. So it's going to be 3 times 1/5 squared, or 1 over 25, times 4/5, and this is just going to be 1/5 cubed. Doing that on the calculator, the probability that we have 2 spam emails is 12 over 125, and the probability we have 3 is 1 over 25. Now, we're looking for the probability that it is 2 or 3, and the word or means plus. So all we need to do is add the 12 over 125 with the 1 over 125, which will obviously be 13 over 125, and that will give us the probability that X is greater than or equal to 2, which is what we've been asked for in the question. You can complete a unique version of this paper by clicking the link. Our website is full of free content to help you with your exams. You can even save your scores with a free account. Enjoy!